Hi students, welcome to today's class. Today's classes we are discussing about algorithm for binary division. Okay, so there are two types of algorithms in binary division, that is restoring division of unsigned binary integers and restoring division of signed binary integers. Okay, so the algorithm assumes that the divisor and the dividend are positive. Here in unsigned binary integers, we are in this algorithm, it is considering that this divisor and dividend are positive. Okay, so there are four registers, that is a M register, a register, a Q register and a CR register, that is count register. Here M register saves the divisor of the uh, problem, and A register it will be A register and Q register, we combinedly save the dividend. Okay, so dividend will be of 2n bits value. So we all know that dividend will be greater, should be greater, and divisor should be lesser. So if the divisor is 4 bit, the dividend should be 8 bit. Okay, it may be 8 bit or something like that. So this 8 bit can be stored by using A register and Q register. Okay, here in division method we are performing left shift operation. Okay, not right shift. In multiplication we have used right shift operation, but in division we are using left shift operation. Okay, so it's jointly performed, that is left shift operation between A and Q is performed here. Okay, here in count register the count of the bit are saved. So during each process the count is decremented, and if it becomes 0, the process will stops. Okay, so these are the steps involved in the restoring division algorithm for unsigned integers. Okay, the first step is load the 2's complement of the divisor into M register, that is M register contains the negative of the divisor. Now in M register, load the M register with the 2's complement of the M value. Okay, next load the dividend into a AQ register. Here dividend is stored in A register and Q register. The dividend must be expressed as 2n bit positive number. Thus, for example, if it is a 4 bit 011, then the dividend will be saved as 0000111. So the dividend will be saved as 2n bits. Okay, so it will be saved in A and Q register jointly. Okay, now M register have divisor and A and Q register have dividend. Okay, now shift A Q in left 1 bit position. Okay, the next step is shift A and Q left in 1 bit position. Okay, then next third step is perform A of A minus M. This operation subtract the divisor from the content of A. The third step is subtract M from A. Okay, so and put the value of the result in A. So A equal to A minus M. So we want to subtract the value of M from A. Okay, that's the third step. Then fourth step is after subtracting, the result will be saved in A if the result is non-negative. Non-negative means if it is positive, most significant bit A equal to 0. Okay, if the result is positive, the most significant bit of A will be 0 since it is positive. So this non-significant most significant bit will be 0 for positive number. Then set Q0 equal to 1. Then the set value of Q0 equal to 1 if the result is non-negative. The result of A minus M is non-negative. Then the MSB of A will be 0. So the set Q0 equal to 1. And also if the result is negative, then the MSB value will become 1. MSB value will become 1 and put the Q0 value as 0. Okay, put the Q0 value as 0 and restore the positive value of A. Okay, after that putting 0, restore the value. So what we want to do is that first we do A minus M, then the result will be saved in A, then look the value of the MSB. If it is 0, then A is positive value. If A is positive value, then put the value of Q0. This is Q0 term will be here. LSB of dividend, put the value of Q0 as 1. If the result is a negative value, then the MSB of A will be 1, and put the Q0 value as 0 and restore the previous value of A. That is, in order to restore the value, we should do A plus M here. Okay. Now, the fifth step is step 2 through 4, as many as there are bit position in queue. Number of bit position in queue, repeat this process until count will become 0. Okay, that's also you can say. Okay, then the last step is the remainder is in A and okay. And the process will repeats until the counter becomes 0 or the dividend becomes 0. Then count becomes 0, then at last the result will be saved in A and Q. We all know that for a division, the result will be a remainder and a quotient. So the remainder will be saved in A and the quotient will be saved in Q. Okay, Q register. So the remainder will be there in A register and the quotient will be saved in Q register. So this is how the hardware implementation of binary division method. Okay, binary division, unsigned binary integer method. Okay, this is the hardware implementation and this is the process involved in this method. Okay, now we can discuss the flow chart of this method. Okay, initial counter value must be the total number of dividend. Okay, that will be, if it is a 4-bit, it will be 4. The count will be 4. If the total number of bits including sign bit is 4, counter value must be n. Okay, implies 4-step division will be completed. Okay, what is okay? Here that's saying if the count is 4, then we want to do 4-step operations of division. Okay, that we have already discussed later. In multiplication case also that's same. Then this flow chart, first start the process, then initially A will take a 0, that is A register, it will be 0. Then M register will have divisor and Q register will have dividend. M register have divisor, Q register have dividend and A is saved as 0. Then count is given to count register. After that, a shift left operation should be done. So in between A and Q, A register, Q register, a 1-bit shift left shift will be done. After left shifting, then we want to do A equal to A minus 1. Do the operation A minus M. Then save this value, this result in A. Then looking the status of A, if A less than 0, A less than 0 means A is negative. If A is negative, yes, if it is negative, Q0 will become, if it negative, the value, MSB value of A will be 1. So, put Q0 equal to 0 and restore the value, that is A equal to A plus M, that is if it is a negative value. If A less than 0, that is no condition, that is A is not a negative value, that is if A become positive, put the value of Q0 equal to 1. So this is the process by looking the status of A. If A is positive, put the value of Q0 equal to 1. If it is negative, put the value of Q0 equal to 0 and restore the A value by doing A plus M. After that, we completed a process, then count will be decrement by 1. If the count becomes 0, then end the process and the quotient will be there in Q register and the remainder will be there stored in A register. If the count is not equal to 0, then the process will repeat from here. Okay, this is how the flow chart of restoring division of unsigned integer method is done. So that's all about today's class. Thank you. Have a nice day.